Assembly language. So you saw a little bit of assembly language, but just to make it more formal, right? Some of you may have this already if you took my class before, but for those of you who haven't, assembly language has what's called directives, instructions, labels, and comments. Directives. What's the difference between directives and instructions? Directives are commands for the assembler. Instructions are commands for the target machine to execute. Okay, so directives means I tell the assembler, okay, let me start generating code from particular address, or let me allocate 10 bytes of memory, or let me define something. Okay, so that's only to tell the assembler what to do. That's directive. Okay, um, instruction is really what you want the assembler to translate to binary, so that the machine can run the binary. Right, machine can't run anything else. A label is a marker for some location. Could be data location, could be a code location. So you can jump to it, or you can read data from it. Comments are really for the programmer and for the TA to grade you. So write lots of comments in your code. Because that's the human readable part. And virtually all assemblers start with a semicolon as the comment character all the way to the end of the line. And then the next line starts something new. Okay? So almost all the assembly languages I know work this way. Here is an example of assembly program in the Intel assembly syntax. So I color code most things. So if you see something purple, that's a directive. So like ORG on the first line or end on the last line, those are directives, or those are commands for the assembler. And if you see something blue, that's the opcode part of an instruction. Okay, so move or add or sjump, right? These are the opcode part. And then black part is operand, or the kind of the arguments. And green part is comments. Okay, so that's how I color code these things. I may miss one or two spots, but that is at least how I intend it. And this is also how Etsim does it too. So what does ORG mean? Well, that means origin, or that's the starting location, or that's where the assembler should set its address to be. And every time you give it an instruction, it increments that address. So it starts filling the locations, right? It tracks the location. So when you have a label, it then knows, oh, okay, it's tracking the location. That label is where its current location is as it's assembling. Now, end, guess what? It means end of the listing. There could be a few other directives, but at least for a simple program listing, this is all you need. And so org 0h means set the starting address at 0. Sometimes you might not want it to start at 0. Why? Because there may be already bootloader that then has some part that it wants you to skip over, or it's always running from 0, so it decides where to jump to run your program. So you might want to start assembling your program at 40 or at 90 or something. You don't know in advance. So, but a lot of times the tool figures out for you. But here we're writing the whole thing, so you should write it. And then move R5 pound sign 25, move R7 pound sign 34, right? All that. So it's just it's generalized to just a sequence of instructions. And then you see the here colon. Well, that's a label, right? That's a location marker. Now there's an sjump. That's a short jump instruction. And in assembly language, short jump takes a label as its target. So it says jump to this label as the next instruction. And here it's just jumping to itself. So it's doing an infinite loop. So you say, Why would you want an infinite loop? Well, that's because here, remember, there's no operating system, no nothing. It's just a bare machine. So if you don't jump to itself, it's gonna run off and uh, running garbage. So for the testing purpose, after you finish running your code, better thing to do is just to jump itself. So it doesn't do anything weird, and you get a chance to look at the results. Because if it's just jumping to itself, it's not going to change anything. Right? All the registers, all the memory is going to be exactly the same. Right? So it gives you a chance to observe the results. So that's how we do this. Okay, so what does this do? Well, I think it's almost readable in that you put the sum constant into R5 into R7, clear the accumulator, A gets A plus R5, A gets A plus R7, and then A gets A plus 12 hex. And that's it, just doing something simple. Well, we'll show you a few more interesting programs. And you could try this out actually. Etsim, I showed you how to do this. And Etsim contains an assembler, so it can actually translate things to machine code. And if you want to play with some assembler, you could. Well, it's more than Windows. I think it runs on Linux as well. ASM51, that's done by some guy in Germany, and last I checked, it still works. So you can type in ASM and then file, but it has to be named .a51 for assembly 8051. And then it's going to produce two files, a hex file and .lst file for listing. .hex file you could actually load in to Etsim. Etsim can open assembly or hex file. And then LST for listing, that is more human readable. So it shows you the assembly and machine code side by side. And the listing file may look something like this. Okay, so that it shows you address in one column, machine code, and as you can see, each instruction may be 1 byte or 2 bytes, sometimes 3 bytes, or it could be more. Okay, and because each hex digit is half a byte, each byte is 2 hex digits. Okay, so I just highlighted a couple operands just to show the correspondence. So like if you have immediate, then it's clearly distinguishable, right? The 25, you can clearly see a 25 hex in the binary. And but like the register R7, that's kind of buried inside that byte. Later, we'll be using SDCC, which is the Small Device C compiler. It has an assembler as well. It's called SDAS. Now, it uses a different syntax from the Intel one. The reason is because there's like an open source project called ASXXXX, cross assembler. That one was adopted by SDCC for assembly code. So this one just slightly different, a little bit more wordy, but it's easy to get used to. So what you have to do is in the literal part, instead of #23H, that's Intel syntax, you do more like C syntax, #0x23 for hex. Okay, okay, that's not too bad. You do have to specify things like segments. So it's something like .area, home, parenthesis, ABS code. So that's for absolute address and then code space. And there's no .end or end directive. And if you want to try it out with SDCC, it installs SDAS 8051 as part of the SDCC commands. And you can have it generate listings. That looks similar. Okay, you can do a hex file as well. So just a quick comparison. Now, so instead of .org, yeah, instead of org, the ASXXX has the .org, the dot in front. Now, these are case insensitive opcodes, so you could do uppercase, lowercase. Doesn't matter. Oh, sorry, it shouldn't be 0H. I think it's just 0 on the right hand side. But yeah, I think I actually tried this. I just typed it on the .org. That's just the C syntax one. Okay, so they look almost identical in most cases. Just directives are slightly different. Now, the Intel assembler or assembly language defines a few other directives. One is called DB for defined byte. We saw that for string. You could also have integer separated by comma, right? So you have a bunch of integers, comma separated. You can have label, but that's optional. So in addition to DB, which actually occupies memory, there's EQU, which is more like a macro definition. Like inside C language, you have pound sign define something. EQU is a lot like pound sign define. So you can have a symbolic name EQU and then some expression. Okay, so it does inlining or substitution. Whereas DB actually says allocate some space and then fill in the bytes in the memory. Okay, so some examples. You can have data1 colon db and then string hello world. Data2 colon db 25. Okay, so db actually says allocate space in the final target image and then fill the data bytes in there. Whereas EQU, that's really for the assembler. So it says define the symbol count to be the expression 25. And so you can say move R3 comma pound sign count is a pound sign 25. Right? So that way, it's just like C programming. C, you do pound sign define count 25. Here it's just a different syntax. So this way, if you have to change count, you change it in one place, right? Macro substitution.